Dear student, previous class we already discussed about the ionization energy. What are the factors affecting ionization energy? What is the variation of ionization energy along the period and group? Now I will discuss about the electron affinity. Electron affinity, or it is called electron gain enthalpy, gain enthalpy, or affinity energy, that is EA, or simply called E. What is the meaning of electron affinity? Suppose take an atom, take chlorine atom having atomic number 17. If I want to draw the electronic configuration, then this is your nucleus, this is your K cell having 2 electrons, and this is your L cell having 8 electrons, and this is your M cell having 7 electrons. This is your K cell, this is your L cell, this is your M cell. If I want to think about the ionization energy, then the amount of energy required to remove an electron from the valency cell of an isolated gaseous atom to form unipositive charge, but electron affinity is the reverse of ionization energy. What amount of energy is released? When an electron from outside, added in the isolated gaseous atom in its lower energy level to form uni-negative ion. Ionization energy means to remove an electron from the valency cell, but electron affinity means the amount of energy released to add an electron in the lower energy level, because the lower energy level are closer to the nucleus, and the electron which is to be added is strongly attracted by the nucleus and it maintains its stability. So remember, the added electron always added in the lower energy level, that is nearer to the nucleus, but the electron which is to be removed always removed from the outer cell, because outer cells are far away from the nucleus, and the electron present in the outer cell are loosely attracted by the nucleus and very easy to remove the electron from outer valency. That's why, so we can write the definition of electron affinity: the amount of energy released when an electron is added in the isolated gaseous atom in the lower energy level to form the uni-negative ion, that is your uni-negative anion. You can think about uni-negative ion, that is your anion. Look at the chlorine atom. Your chlorine atom having 17 electrons. It wants to stabilize by gaining one electron, that is your total number of electrons is 18 and it converted into Cl minus. That means the chlorine atom always want to gain an electron from the outside. That means outside means from other atom, and it attains the inert gas configuration. That is your 2, 8, 8. Then what amount of energy is released by the chlorine atom to gain an electron from the other atom and to convert it into Cl minus ion, and here the added electron must be present in the M cell, because before M cell, K cell and L cell are present, which are lower energy level as compared to M cell, but these cells are completely filled. So no electron will be added in K cell, L cell, and the added electron must be added in the M cell. So what amount of energy is released by chlorine atom when an electron will be added in the M cell of the chlorine atom and converted into Cl minus ion? That amount of energy is called electron affinity. Next point, the electron affinity is expressed in electron volt or kilojoule per mole or kilocalorie per mole. Next point, suppose I want to think about the EA1, EA2, EA3, then what is the meaning of EA1, EA2, EA3 dotted like this? You know also about IE1, IE2, IE3 like this. I1 corresponds to the first ionization energy, which is required to remove the first electron from the valence cell. I2 corresponds to the second ionization energy, which corresponds to removal of the second electron from the valence cell. Like that, we can also think about EA1. EA1 means the amount of energy released when the first electron is added. EA2 means the amount of energy released when the second electron will be added. Like that, you can think about also EA3, which corresponds to the third electron added. Suppose I will think about the N3 minus. Nitrogen having 7 electrons. Suppose 1 electron is added with nitrogen, it is converted into N minus. And what amount of energy is released? That is corresponds to EA1. Similarly, next suppose second electron will be added, then the electron affinity is considered as EA2 and it is converted into N2 minus. Like that, you can also think about suppose third electron will be added with N2 minus and the electron affinity considered as EA3. N2 minus is converted into N3 minus. Suppose I want to think about the nitrogen atom. Nitrogen atom having electron configuration 2, 5. That means I can draw the electron configuration like this. K cell having 2 electron, L cell having 5 electron. This is the electron configuration of nitrogen. When the first electron will be added in the nitrogen atom, then what will happen? It is converted into N minus, and the electron configuration is like this. This is your 2 having 2 electron in the K cell and 6 electron having in the L cell. 1 electron will be added in the lower energy level and that converted into 6. This is your K cell, this is your L cell. Now the atom will be converted into N minus. Here the nitrogen is considered as an atom and it is your neutral. So when I will add an extra electron, the neutral species and the negative species do not repel to each other. But remember, when I will add the second electron to the N minus, then what will happen? This is your charged species, this is your negative charge species, and the electron having also negative charge. That means there is a repulsion between N minus and the electrons. As a result, it is very difficult to add an electron in the L cell in this case. That means it is very difficult to add the second electron in N minus because N minus already charged species. Like that, if you think about the third electron, then the N minus now become converted into N2 minus. Here also the negative charge will goes on increases and there is more repulsion created between the third electron and the N2 minus. So the third electron will be very difficult to add in the N2 minus because there is more repulsion. That means when the first electron added to the neutral atom, there is a nitrogen, there is no repulsion, it is very easy. That means we can think about that the atom having more electron affinity. But when I will add the second electron, then the atom already converted into ions, that is a negative ion, so there is a repulsion between the negative ion and the second electron which is to be added. In case of first electron added, there is no repulsion, but in case of second electron added, there is a repulsion between the charged ion species and the second electron. Like that, if you think about the third electron, then there is an increase in the repulsion between the electron which to be added and the ion which will carry the third electrons. That means we can write a point, electron affinity goes and decreases like this.
EA1 greater than EA2 greater than EA3.
So we can write a point during addition of second, third order electron, the atom already has a negative charge on it. So the addition of second, third order electron is to be done against the repulsion from the anion. To overcome such repulsion, extra energy is used during addition of second, third order electron. As a result, the addition of first electron is exothermic, means there is a release of energy, while addition of second, third order electron is endothermic. That means endothermic means gain of energy. Exothermic means loss of energy. That is a release of energy. I will discuss about the next point. Suppose an atom having more electron affinity. That means you think that the atom having more tendency to gain the electron. The atoms having more tendency to gain the electron, and it has more tendency to convert into the anion. The atom having more tendency to gain the electron and convert it into an ion. That means it has a more tendency to help the another atom to lose the electron, and that lost electron is gained by this atom. We know that addition of electron is called reduction, loss of electron is called oxidation. The atom who is having more electron affinity means we think that when we will add an electron to this atom, then this is your called reduction. This is your called reduction. That means the atom undergoes reduction. As a result, one electron is added to the atom. But the added electron must come from the another atom. That means we think that the another atom loses this electron and this electron gained by the atom. There is a loss of electron and there is a gain of electron. In this case, we can think about the ionization energy. In this case, we think about the electron affinity. This atom helps to this atom for the loss of electron because this electron is gained by this atom. Loss of electron is called oxidation. This atom helps to this atom for oxidation. That means this atom is your called oxidizing agent. This atom is your called oxidizing agent. No doubt it undergoes reduction, but it helps to another atom for oxidation, so it is called oxidizing agent. On the other hand, if you will think about this atom also helps to this atom for reduction. So this atom is considered as the reducing agent. Is called reducing agent because this atom helps to this atom for reduction. So it is called reducing agent. It undergoes oxidation. It is called oxidizing agent, but it undergoes reduction. Electron affinity means addition of the electron. That means we can think that more is the electron affinity of an atom, more is the tendency of that atom to gain the electron and become to convert easily into the anion, and it have a more oxidizing character. That means it acts as a strong oxidizing agent. That means it helps to another atom for oxidation. So we can write a point: more is the electron affinity, greater is the tendency to accept an electron, and greater is the tendency to convert into an ion and behave as a strong oxidizing agent Next point, the non-metals having high electron affinity. High electron affinity. The elements present in the p block are having more electron affinity. We know very well about the p block element. The elements whose last electron enter into the p orbital of the valency cell are called p block element. In modern periodic table, the p block elements are present right side of the periodic table. The p block elements are generally 13, 14, 15, 16, 17, 18 group elements. They have generally high electron affinity. That means these elements have more tendency to gain the electron and convert it into anions. Next I will discuss about the variation of electron affinity along the group and along the period. If I want to think about the electron affinity along the period, then take two examples. One is your lithium, another is your fluorine. We know that lithium having atomic number that is your 3. If I will think about the electronic configuration, then this is your K cell having 2 electron and L cell having 1 electron. If you think about the fluorine having atomic number 9. If I will draw the electronic configuration, this is your 2, this is your 7. K cell having 2 electron, L cell having 7 electron. This is your K, L, this is your K, L. We know that the atomic radius of lithium is more than fluorine. Here the nuclear charge, that means we think about the effective nuclear charge for an electron is less because your distance is more. But if you think about the fluorine having more effective nuclear charge as compared to lithium because it has a small size. The atomic radius of fluorine is smaller than the atomic radius of lithium. So the distance is small. Here L cell, here is also L cell, no doubt. But when I will add an electron to fluorine, then fluorine will attract the added electron more because it has more effective nuclear charge due to the small size. Because the electron is so closer to the nucleus as compared to the lithium atom. Because the L cell in case of lithium atom is far as compared to fluorine atom. So here the added electron more attracted by the nucleus as compared to here, that means in lithium. So we can think that the atomic radius of lithium is greater than fluorine. So the electron affinity of fluorine is more than electron affinity of lithium because due to size, that is your atomic size. More is the atomic size, less is the effective nuclear charge to the added electron. As a result, less is the electron affinity. That means we can write a point from left to right. The atomic radius goes on decreases. As a result, the electron affinity goes on increases. The electron affinity goes on increases from left to right along a period due to decrease of atomic radius. Take an example. electron affinity of fluorine is more than electron affinity of lithium. Both fluorine and lithium present in the second period. Next point is if you think about the element present in the group,
Suppose take an example.
that is your lithium, another is your sodium. The atomic radius of lithium is smaller than the atomic radius of sodium. As a result, we know that the electron affinity goes on decreases with increase in the atomic radius. That means we can think that the electron affinity goes on decreases from top to bottom along a group due to increase in the atomic radius. No doubt there are some exceptional cases also found in both period and group, but generally we think about this along the period atomic radius decreases, so the electron affinity increases, but along the group the atomic radius increases, so electron affinity decreases. For this case we can take an example. Electron affinity of lithium is more than electron affinity of sodium. Next I will discuss about the factors. Already discussed one factor, that is the effect of atomic radius. So we can write first atomic size. Atomic size related to the atomic radius. More is the atomic size, less is the electron affinity, because more is the atomic size, less will be the effective nuclear charge to the added electron. That's why more is the atomic size, less is the electron affinity. Next is your nuclear charge. Obviously, more is the nuclear charge, more is the electron affinity, because the added electron must be more attracted by the nucleus. If the nucleus having more nuclear charge, then it has more tendency to gain the added electron. So we can write more is the effective nuclear charge, more is the electron affinity, more is the electron affinity. Next factor is your stability. Remember an important point: every atom have a tendency to attain the stable electronic configuration. They do not want to attain the unstable configuration. Suppose if you think about neon. Neon having atomic number 10, its electronic configuration is 2A. Due to the presence of 8 electrons in the valence cell, that is your L cell, it obeys the octet rule and it is considered as the more stable. Suppose I want to add an electron into the neon atom, then it will be converted into 281 configuration. That means this is your unstable configuration. So neon do not want to be unstable. After adding one electron in the neon, the configuration is your 281. So neon do not want to attain the unstable electronic configuration because before adding one electron, the neon atom already stable due to the stable electronic configuration. So remember, and stable atom do not want to receive the added electron because they are already stable. They do not want to attain the unstable electronic configuration. So remember, if an atom is more stable, then it have less electron affinity. Maybe it is equal to 0. So remember, more is the stability, less is the electron affinity. You can take an example. Neon is more stable than fluorine. So we can write neon having less electron affinity than fluorine. The electron affinity may be 0 for neon. Due to this factor, that is the stability, there are some exceptional found in the arrangement of the elements according to the increasing or decreasing order of the electron affinity. Next I will think about the penetration power. Fourth number factor is penetration power. In the previous class we already discussed about the penetration power. Penetration power means the ability of an orbital to gain the electron. That means more is the penetration power, we think that more is the tendency to attract the electron towards itself. More is the tendency to attract the electron towards itself, indicate that more is the electron affinity. That means more is the penetration power, we can write more is the penetration power, more is the electron affinity. We know that s orbital having more penetration power than p, than d, than f. So s orbital having more electron affinity than p, than d, than f. This is your order of orbital according to the penetration power. This is the order of orbital according to the electron affinity. That is all about your electron affinity.